In this presentation on number system, we are going to talk about the decimal representation of rational numbers. So we know that a rational number, it is a number which can be expressed in the form p by q, where p and q are integers, and the denominator q is not equal to 0. So if we manually divide these two numbers p and q by long division method, we have two possibilities that can arise. The first is that the remainder will become 0 and the division process will conclude after a finite number of steps. So in this case, the decimal expansion that we will obtain, that will be having a terminating representation. We call that number is having a terminating decimal representation. So if we look at an example over here, suppose I am dividing the number 13 by 5. So on dividing these two numbers, what we obtain is, it is 5 to the 10. When we subtract this value, the remainder we are left with, it is 3. Now we add decimal over here. On adding the decimal, we will have 0 over here. And now the next term we will obtain, it is 5 6 is a 30. So we are saying in this case, the remainder now it will become equal to 0. So we are saying that the division process, it comes to an end after a finite number of steps, and this kind of representation of the rational numbers, it is called the terminating decimal representation. The second case we have is, for the rational number, the second case that can arise, it is that the remainder will never become 0. So we are saying that we are having the non-terminating decimal representation. But it is important to note over here that whenever the number is rational, we will get a repeating string of remainders. So what we mean to say from this is, we are saying, suppose we are dividing the number, say 2 by 3. So what we obtain in this case is, we are saying 3, this 2 is less than 3, so we will add decimal over here and we will have 0. When we add decimal, we get 0. Now on dividing these two numbers, what we obtain is, it is 3 6 is a 18. When we subtract this value, the remainder we are left with, it is 2. Decimal is already there, we add 0 over here. Now it is 3 6 is a 18. When we subtract this value, the remainder is again 2. Now again, if we multiply 3, we get 3 6 is 18, and now again the remainder, it is 2. So we can see that this process is never going to end, and we will obtain the quotient in this form, it is 0.6666 and so on. So this is the case we are saying that the remainder never becomes 0 and we obtain a repeating string of remainders. We have obtained a repeating string of remainders. So what we can note from this case is that in this case, we get a digit or a block of digit repeating in the decimal expansion. So in this particular example, we are saying this 6 is repeating again and again. Now we give some more examples related to terminating decimals and non-terminating and repeating decimals. So first example we have over here, we are considering the number, say 1 by 4. So if we divide this number 1 by 4, clearly this 1 is less than 4. We will add decimal over here, we will get 0. Now we will have 4 to the 8. When we subtract this value, the remainder now we are left with, it is 2. Now we have already added the decimal, so we have 20 over here. So we get 4 5 is 20, and on subtracting this value, the remainder will become 0. So we are saying that the value of 1 by 4 we are getting over here, that is equal to 0.25. So this is a terminating decimal representation because the remainder becomes 0 after a certain number of steps. Next, suppose we are talking about the number say 5 by 8. So if we divide these two numbers, again 5 is less than 8. We will add decimal. We are dividing 5 by 8. We will have the answer in this form. We are adding decimal over here. Now we have 5, 6 8s are 48. When we subtract this value, the remainder we are left with, it is 2. We have decimal over there, so we add 0. Now 8 2s are 16. Again subtracting this value, we obtain the remainder as 4. We add 0 over here. Now 5 8s are 40. The next term we have, it is 5 8s are 40, and on subtracting this value we get that the remainder is 0. So we are saying that the decimal representation of 5 by 8, it is 0.625. So these are the examples. These are two examples of terminating decimal representations of the rational numbers. Now next we are going to give the example of repeating or recurring decimal representation. So suppose we are talking about, in this example, we are talking about the number 3 by 11. So when we divide these two numbers, we are dividing 3 by 11. So clearly 3 is less than 11. So we have to add the decimal and we obtain the division in this form. We are having the decimal over here. We add the 0. Now we have 11 2s are 22. When we subtract this value, we obtain the remainder is 8. Decimal is already being added, so we will get 0 over here. Now 11 7s are 77. When we subtract this value, we are getting the remainder is 3, and 0 we already obtained because decimal is already there. Now look at this case over here. Now the remainder in this case, it is 3, and when we have started this question in this step, we have this value is 3. Now what will happen? The next step we are going to do, it is 11 2s are 22. When we subtract this value, now the remainder will be 8. So compare these two values. We are saying this gives the remainder 8. We have remainder 8 over here. Now if we move on to the next step, what will happen? We are saying we will have 0 over there. Again we have 11 7s are 77. We subtract this value, the remainder is again 3. It means we have again reached this remainder 3 we have already over there. It means when we repeat this process again and again, we will again obtain the remainder as 3 as 8, as 3 and 8. So we are saying that the quotient, it has the repeating block 2 7 2 7 and so on. So we are saying that 3 by 11, we can write its value, it is 0.2727 so on. And it is important to note over here that in recurring decimals, we place a bar over the first block of the repeating digits and omit the other repeating blocks. So what we mean to say is that this number 0.2727 so on, we can write it in this form. So this bar above this number, this bar we are talking about, this represents that this digit 27, this block of digit, it is repeated again and again. So when we are writing the value of 3 by 11, we can write it like 0.27 bar, and it will mean it. What it implies is that this block 27, it is repeated again and again. Now the next example we have is this number 15 by 7. So if we divide 15 by 7, what we obtain is, we are dividing 15 by 7, so we will have 15 7 2s are 14, and on subtracting this value, the remainder we are left with, it is 1. We will have 0 because we are going to add decimal over here. Now 7 1s are 7. Again subtracting this value, we will have 3, and we will have 0 over there because the decimal we have already added. Next is 7 4s are 28. When we subtract this value, the remainder we are left with, it is 2. We are adding 0 over here. Then 7 2s are 14. we will have the remainder 6, so the value we obtain it is 60 over here. Decimal is already there. So 7 8 is a 56, the remainder is 4, we will get 40. Then 7 5 is a 35. When we subtract this value, now the remainder left it is 5. Then we have 7 7 is a 49, and the remainder we are left over here, it is 1. Now look at these two values. We are saying the remainder we are having over here, it is 1. In this step also we have remainder 1. It means that this block will now keep on repeating. So if we move on to our next step, we are saying we will have 0 over here. The next step we will have, it is 7 ones are 7. On subtracting we will get 3. Then 7 fours are 28. On subtracting we will get 2. So we are saying what is happening over here is, we have this remainder 1. In this case we have this remainder 1. Then we have remainder 3. In this case the remainder we have 3. Then we have remainder 2. We have remainder 2. It means that this division process is never going to end, and we will get the quotient in this form. So we are writing that 15 by 7, we can write it is 2.142857. Then again we are getting 142857 and so on. And this block that is repeating again and again, we can write the bar over there on this block, and we can write this number in this particular form. Now the next we have is the term length of period. So we are saying that when we are having the non-terminating repeating decimals, then a block of digits is repeating, and this repeated number of decimal places in a rational number is called the length of its period. So what we mean to say is, suppose I am talking about the number 2 by 3. The decimal expansion of this number, it is 0.6 bar. So this digit 6 is repeating again and again. So in this case we are saying the length of the period, it is 1. That is, there is one digit that is repeating again and again. If I am talking about the number 15 by 7, we have the value in this way. We have seen in our previous slide. So in this case, this block has 6 digits that are repeating again and again. So in this case, we are saying the length of the period, it is 6. Further, we have the result that the number of entries in the repeating string of remainders is less than the divisor. That is, the length of the period is less than the divisor. So in this particular case, we are saying only one number 6 is repeating. It means that the length of the period is 1 and the divisor, it is 3. So clearly the length of the period, it is less than divisor. In the second case, we are saying a set of 6 digits, that is 142857 is repeating again and again, and the divisor in this case, it is 7. So again what we get is that the length of the period is less than 7. So we have the result that the number of entries in the repeating string of remainders is always less than the divisor. The next question we have is, find the decimal expansion of 1 by 7, and can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7 and 5 by 7 without actually doing the long division process. So first of all, we have to calculate the value of 1 by 7. So we are dividing this number 1 by 7. So it is less than 1. So we will add decimal over there. We have decimal over there. Now the first step we have, it is 7 ones are 7. When we divide this value, we get 3, and decimal is already there. So we get 30 over there. The next step we have, it is 7 4s are 28. So the remainder in this case we obtain, it is 2. We add 0 over there. Next is 7 2s are 14. On subtracting this value we get 6. 0 is already there. Then 7 8s are 56. The remainder in this case we have, it is 4. We add 0. Now next we have 7 5s are 35, and on subtracting these values we get 5, and 0 is already there because of the decimal. Then we have 7 7s are 40. 9. Now the remainder in this case, it is equal to 1. So again comparing these values over here, it is 1 over here, we have 1 over here. It means that the answer we are going to obtain, that will be, we have 1 by 7, that is equal to 0.142857, and then this block will keep on repeating. This block will keep on repeating and we will have the answer in this form. So you can check it over here. If we add 0, we will have 7 ones are 7, remainder will be 3, we add 0 over here, then 7 fours are 28, remainder will be 2, and this process will keep on like this. So we are saying that this block 142857, it is repeating again and again. Now in the second part of this question, we have to find the value of 2 by 7, 3 by 7, 4 by 7 and 5 by 7. So we are going to multiply these terms. We are saying we have the value of 1 by 7 is given. So if we multiply the value of 1 by 7 by 2, we obtain the value, it is 2 by 7. So we are saying, what we have to calculate? We have to calculate 2 into this number. It is bar over there. So if we multiply these terms, we are going to multiply this block with 2. What we will obtain is, it is the last digit we are having over here, it is 7. So we have 2 7s are 14. So the digit we obtain over here, it is 4. Then 2 5s are 10 and 1, it is 11. Then we have 2 8s are 16 and 1, that is we have 17. Then we have 2 2s are 4 and 1, it is 5. Then 2 4s are 8 and then 2 1s are 2, and we will have decimal over here. Now we are saying that this complete block, it is repeating again and again. So we are saying that we have calculated the value of 1 by 7 using the long division method. Then we have multiplied this term with 2 and we obtain the answer in this form. And this block, now the block 285714, 285714 will repeat again and again. Similarly, if we have to calculate the value of 3 by 7, we are going to multiply 3 with 1 by 7. We obtain the answer in this form. Next, we have to calculate the value of 4 by 7. We are going to multiply 4 with this value of 1 by 7. So when you multiply 4 over here, you will obtain the answer in this form. And last, we have to calculate 5 by 7. So you can check at your own that on multiplying this number with 5, you will obtain the answer in this form.